Okay, well, it looks like we're live. Hello, everyone. How is everyone doing today? We're here for lesson 9 of the Learn Programming with Python course. Today's lesson is going to be, as usual, an hour and 30 minutes long. Hey, Luke, how you doing, man? It's always good to see you, bro. So yeah, I'll give it like 2 more minutes. We can go ahead and just get started. And while we're waiting, actually, if you guys were here last lesson, so lesson 8, you might have known that there was an error with recording, and oops, looks like I'm actually on my OBS. Anyway, there was an error with the recording system on Teach, and so my lesson 8 didn't get recorded and it didn't get put back up. So what we're going to do is we're actually going to do a brief sort of quick overview of dictionaries when we go ahead and start, just so that if anyone's joining us and they weren't here from the previous lesson, that they're still able to follow along with what's going on. And then as soon as we're done with that, you can probably see from my tabs that I've gone ahead and queued up some projects that we'll start working on once we talk about a couple more things. So we're coming to the end of our first learning phase, and we're transitioning into our first like building phase, if you will. So I think we've got everyone. So let's go ahead and get started. So as I said before, we're going to start with a quick review of lesson 8 because the recording isn't up. So if anyone does want to have to reference that sort of content, then they can do that here. So lesson 8, let's try to do it as quick as possible. I'll give myself like 15 minutes. Okay, so lesson 8 was all about dictionaries. And dictionaries are these things called data containers. Now, data containers are something that we talked about earlier. So we talked about tuples and we talked about lists. The difference between tuples and lists and dictionaries is that dictionaries work on this key value basis. So you have a key, that key is assigned to a specific value. So I've created a dictionary here, and this is from a project that we worked on near the end of our last lesson. But in this right here, I have created a dictionary, right? This is my dictionary, and I've stored it to the inventory variable. How do I know this is a dictionary? Well, it's surrounded by these curly brackets, first of all, and you'll notice that there's 2 pairs of things, right? Cereal 5, milk 2. So in this cereal 5, you can see that cereal is my key, right? It's the first thing there, and 5 is my value. So again, this was an inventory management system that we built. So we were saying we have 5 cereals, we have 2 milk gallons or whatnot. That's really quick how to create a dictionary. And then to add to a dictionary, basically what you do is you use your bracket notation to put the key you want to add and then assign it to a value that you want to add, and that gets added into your dictionary. Then to remove from a dictionary, you can use your del keyword. You use your del keyword and you just reference the key that you want to delete from your dictionary. And then that's really just it. Yeah. Changing a value is actually the same as adding a value. So you just tell it the key that you want to change and you give it the new value that you want to add. So let me actually go through and run through this whole program. And actually, let me zoom out so the code doesn't, overlap like it does. So if we run this, our code asks us, what operation would you like to run? And that's this first input statement right here, right? We're within this while true loop. So what operation would you like to run? Well, we have a multitude of options. We have P, D, A, C, Q. Now, P stands for, where is it? I don't think I have it. Yeah, print inventory. D stands for deleting an item of my choice. A stands for adding an item. C stands for changing an item. And Q stands for quitting the program. So if I want to print my current inventory, which is just this right here, I'll press P. There we go. Now, if I want to add something, right, I'll put A. If we come down here to the adding code section, right, so we're right here. It's going to ask us, what item would you like to add? I will say yogurt, right? Now, first it's going to check to see if that item already exists. In our case, it doesn't exist, right? Yogurt's not already a valid key. Again, we're using our in keyword to check that. So because it doesn't already exist, it's not going to ask us what value do we want to give that item. I'll say we have 10 yogurts. And that's how it adds it. It takes that key, which is yogurt, and assigns it to that value within my dictionary. So if I print our dictionary now, cereal 5, milk 2, yogurt 10. Awesome. The next thing our program can do, right? So we've touched upon print, add. Let's look at delete. So I'm going to press D right here. And this time I'm going to use this in keyword here. It seems like the 30th of July session is live now, so I think this class is not going to. Oh my Jesus. Let me take a look. That's so odd, because if you're looking at the homepage, when I looked at it earlier, it said the 23rd of July, but now it's saying the 30th of July. Oh wow. In that case, let me just go ahead and start a recording as well then, just in case, so I can upload it if I have to. Upcoming classes. Well, you know what? I started the recording, so I guess we'll just deal with it. Not ideal. Not ideal at all. It says upcoming classes are the past classes. Yeah, I think I'm just going to have to delete that whole thing and just whatever. Anyway, let's just go ahead and continue. I started the recording, so if anything does go wrong, I'll just put the recording up. So it's asking what item. Yeah, thank you for letting me know, though, because if you hadn't told me, I would not have started the recording. So now it's going to ask us what item we want to delete. And so here's where we're going to show the sort of usage of our in keyword. So right now I have cereal, milk, and yogurt as valid keys. Let's say I wanted to delete, we'll say chocolate, as that item does not exist. So we're checking to see if that item is inventory, then we can delete it. Otherwise, you can say that the item does not exist, and that's what happened here. So now if I come back and I type milk, oops, sorry, I have to press delete and then milk. If we print that, our milk is gone. And again, the changing is sort of the same way. And I'm actually going to call it there with our lesson 8 overview. Let's go ahead and transition. I think everyone's okay with this. I think everyone, at least I remember from the last lesson, had a pretty good grasp of what was going on with dictionaries and whatnot. And frankly, we won't be touching upon dictionaries as much in our little projects today. Our projects are like really basic, just starting off, making sure that we understand everything from several lessons ago. Okay, I'm seeing yes from Maria, so let's go ahead. I'll come over here to this different REPL. I call this Teach Projects. Awesome. So before we go ahead and we build these projects, there's 2 things I want to go over, just 2 last things. And the first thing is something called importing code. Now, what do I mean by importing code? Well, if you remember from our earlier lessons, we have been using a lot of functions, right? A lot of things that come built in with Python, right? Our str function, our input function, our int function, our length function. These are all things that we've created, that we haven't created, right? That's something that Python gives for us to use, right? So you can open up any Python file and you'll be able to create this length function, right? There's no need for you to have to go def length and tell it what to do. It already works out of the box. Now, Python actually has more built-in functions, more built-in functionality. However, it's not available to us as soon as we open the code, right? So say, for example, my print statement is a function that I can use as soon as I open up the code. There's no need for me to do anything else. If I go print hello world, then this works out just fine. However, Python has a lot more functionality. And what we're going to be doing is we're going to be touching on 2 of those functionalities, and because they're the most fun to work with, they'll make our beginner projects a lot more interesting. And so that built-in functionality that we can't immediately access, we have to import it. You have to tell Python, hey, you know this random thing that you can do? I want to be able to do that inside the scope of this program. So importing is basically where you take code that has already been written and you're able to use that code within the scope of your program. So an example we'll be using is Python has a library called the random library. And that library allows us to do random number generation. Now, right now, I can't use my random library, but if I import it, then I'll be able to have the ability to access all those functions to create random numbers, which is pretty awesome because you can make like guessing games and stuff like that. So let's go ahead and actually start with importing our first library slash package. And again, I said we're going to work with the random library. So we're going to type import. If I run, no error, no problems on my console. So we've successfully imported the random library. What does that mean? That means all of the code within this random library, within this random package, right? We can now use it within our code because we've told Python to sort of import it, to open the doors for us to use it. So there's really only one function that we're going to be using from the random library right now. As I said, the random library is a collection of a lot of different functions and a lot of different code. But right now, we're only going to be talking about the rand int function. And if you look at this rand int, the little dash there, so you can see it just stands for random integer. That's what rand int stands for. So cool. So right now, we've talked about why we import code, right? So you don't have to rebuild the wheel. So you can use functionality that already exists. We've imported our random library, right? We've done that without any errors. And now we're going to be talking about the randint function. So this randint function allows us to generate random integers within a given range. So we give it the range and it gives us a number between that. Cool. So in order to access our randint function, we say, we'll just make a variable, actually, we'll call it random number. Okay. Now, to access this randint function, I can't just type randint. If I type this, I get an error. Randint is not defined. What I have to do is I have to say random.randint. If I run this, now we says we're missing the arguments that we have to give it. So we're missing the range that we have to give it. But that's a different error that we can address easily. So what does this say? Let's go through this English style. Python, can you allow me access to the random library? Python will be like, yeah, of course I can do that. And then you'll say, hey, Python, I want you to make a random number that is from the random library and uses the randint function. So this is the random library, right? That's what we've imported. And from there, we're able to access the randint function. So is everyone okay with how we're importing a library? And then from the library that we've imported, we're accessing this, this function. Okay, I'm not seeing any questions, so I'm just going to keep going then. So we've put down our random.randint, and now we just have to give it two arguments, right? We have to give it our starting and our stop value. And what's interesting with randint is if you remember our range function, right? We have our start, and then our stop is everything that up to but not including. However, with randint, it is inclusive. So if I put 0 to 5, then 0, 1, 2, 3, 4, 5 are all fair game. So it's all the way up to and including the end value of your range of numbers. So if I wanted to have a random number from 1 to 10, I could say, well, I can start at 1 and 10. Pretty straightforward. If I run this, no errors. If I go ahead and print this random number, we get 9. If I run this again, we get 9. Now we get 10. Now we get 9, 1, 5, 6, 3. So every time we're running it, we're getting a different number. And actually, just so you can see, I'm just going to make a for loop that runs for, let's say, 10 runs, 10 loops. And we're just going to copy this, clear this. We should get 10 random numbers when we run this. And that's exactly what we get. We get random numbers. So cool, we're able to finally generate random numbers within whatever range we want, at least if they're integers. And that's pretty cool. Now, the random library is pretty straightforward. Again, if you guys have any questions, I think the real thing that might be confusing is how we're accessing this function from this library. But I'm not seeing any questions or issues so far. So let's go ahead and talk about the next library. So the next library I want to talk. Something just happened. I think I just cut out. Anyway, the next library that we're going to talk about is called the, I got disconnected. Am I back? Okay, I don't know what happened there. But yeah, okay, we're all good. All right, sorry about that, guys. So we've talked about our random library. We've talked about generating our random integers. So I'm actually going to clear this right now. And now we're going to talk about the time library. Now, the time library, again, we're just going to be talking about one function from there. And actually, let me rewind a little bit. With our random library, there's actually one more function. So we have our random function that allows us to generate random integers within a given range. We also have our choice function. Now, our choice function allows us to pull random values from a list or a tuple. Let's explore this a little bit. I'm going to have a sample list of students. We have Maria, we have Luke, right? Who else do we have? I don't know. Ed, David. Pretty basic names right there. Ed and David. I use them like all the time. Anyway, so we have our list of students, and we're going to use our choice function to give us a random value from this. So just pull a random student's name. So I'm going to call this random student. And if you remember with our randint function, right, I type random, and then I type dot randint. So Python knew I was accessing the randint function from my random library. I'll do the same thing here. From my random library, I want to access the choice function. I run this, I get an error. Choice is missing one required positional argument, sequence. So by sequence, it means list or tuple. So what sequence do I have? Well, I have my students list. So I give it this, random.choice from my students list, and then we'll just print out who that random student is. Oops, student. If I run this, we get David on our first run. On our second run, we get Ed. Then we get David again, Maria, David, Ed, Luke. So these are the two functions that we're pulling from our random library right now. And of course, if you want to see if there's more functionality to the random library, just Google it. There's so much that this library can do. It's actually amazing. So yeah, random function, generate random integer with our given range. Choice function, from a given list or tuple or sequence, pull a random item from there. So that is our random library so far. Cool. I'm going to go ahead and clear this now. I think everyone's okay with this. Everyone's okay with our random library and how we're able to do these things. Okay, awesome. And again, our projects today will actually be using our random library a little bit more. So I'm going to go ahead and clear that. And now we're going to be talking about the time library. And from our time library, which is even bigger than our random library, we're just going to be using one function. And that is the sleep function. Now you can probably imagine what this does. It just stops your code from running for a couple of seconds. It adds a natural pause, which, depending on what you're doing, might seem more appropriate. Now, with our sleep function, you don't have to save it to a variable or anything. You're just adding a delay in your code. So you say time, or actually you have to import it. Import time. And you say time.sleep 5. I run this. You see it's waiting. It's not done yet executing. And now it's finished. So to show you how this is working, I'm just going to have print start, print, and then you notice the sleep is between these two. If I run this, what should I hope to see? Well, it'll import the time library. That shouldn't take up any time. It'll print start, and then 5 seconds later, it'll print end. So if I run this, I'm going to count to 5. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, and there you go. It has printed end. So we added a 5-second delay to our code. Now, when I was first starting off with programming, what I would do is in my little projects I used to make, I would have, this welcome to this game by Varun Patel. I'd put a little delay and then it would start up like it was like loading, like a little loading screen. I used to print that out. And again, programming, sometimes you have to add delays to your code just so that things have time. So just so that things have time to load and whatnot. Maria asks, how can you know if it's 5 seconds, minutes, or hours? So this sleep function always takes seconds. Always takes seconds. So if I wanted 5 minutes, I would put 300. Because again, 60 seconds in a minute, 5 minutes, so 60 times 5 gives me 300. So it always takes seconds. Good question. So that is our random library. That is our time library. Pretty cool stuff. Now, I said at the earlier that we have 2 things we wanted to cover. And so aside from importing the code, the last thing I wanted to touch upon was special characters. Special characters. Now, I actually touched upon this on my first review lesson, I think 2 weeks ago. But again, repetition, we got to make sure we're practicing. So the first special character is basically what we call a new line. And the other one we're going to talk about is called a tab. So special characters are strings, which when you print them out, they don't just print out normally to the console. They add a special functionality. So what do I mean by that? Let me create an example where we have our print hello world, right? Pretty straightforward, pretty basic. If I run this, we get hello world. This is to be expected. My new line character looks like this. So what if I took this new line character and I put it right here? Hello, space, new line world. Do you think it'll just print out something like this? Hello, world? Well, let's see, because it doesn't just print out normally, it has its special functionality. So if I run this now, it's taken me to a new line. So hello, and then this world is not on the same line anymore. So what is this backslash n doing? Well, it's creating a new line. So it's sort of like, if you're typing, right? If we just type this out for what it is, right? So we have hello, hello, we have that space, and then I see this backslash n, and it's like me pressing enter, and then I type in the rest of it. So that's why it formats out a little differently. With our tab, you can probably assume what it does. It just adds a tab. So it's just like you're pressing tab normally from your keyboard. So if we have hello world, right? I put a backslash T here, because that's what tab is. It's backslash T. Get hello. And I see a little bit more of a space. So it's sort of like it's typing hello world. These are these are just a small section of your special characters. There's a lot more that do different things. But the new line and the tab are definitely the more common ones. Again, these are things I'm touching upon really quickly because they're not super duper important. They're more for just formatting your things so they look nice. You have more, control over things, how things look when they're being printed out to the console. So backslash T is used for double spacing. I wouldn't say it's double spacing. Again, it's just like you're pressing the tab button on your keyboard. So it moves it to a predefined point. But again, it's just, not super important. You'll probably use this new line character more than anything. But let's say you wanted to print out something, right? You wanted to print out all the items in a list. Okay, let me create an example where a special character might be nice to have. Let's say we have our students again. Maria, oops. Put that in a list. Maria. So we could say for student in students, print student. Oops. If I run this, it looks fine, right? I'm printing all these things out nicely. But what if I want to add like a greater layer of presentation so it looks a little bit nicer? Well, I can say something up here like my students are, and I can use my comma, something like this, slash t. If I run this now, it looks a little bit nicer. So what am I doing here with our print statement? I'm putting that backslash t so we get that tab, and we're putting our dash, so it's like like a bullet point almost, and then you have student with the space afterwards. So again, it's just for formatting. And again, if I wanted to make it even different, even nicer, I could add like a new line between all of these. So it's like it's pressing enter, and then it's pressing tab, and then it's typing out, everything out like that. So again, just for formatting, because we're gonna be doing projects where you'll want to format it so it looks nice, and it just looks more appealing, which is why I'm bringing it up now and not earlier. So is everyone okay with our special characters, our importing rather, of different libraries and stuff like that, using functions tied to specific libraries? Can you use bold? I don't think so. These are just for general manipulation of your white space. I think bold is more of a formatting thing. I think Python does have something like that, but I'm not familiar with it. It would definitely be worth doing a Google search for. I'm sure there are some ways to do it, but not that I have touched upon. But yeah, so far, so good, right? I think everyone's just doing fine. Cool. So now that we're done with the last two things we want to cover, we can finally transition into our project building. So I'm going to go ahead and clear this. Let's zoom this in a little bit. And we're going to start off really simple. The first project we're going to build is we're just going to build a coin flipping game. Now, with this coin flipping game, we're going to be using the random library to pull either heads or tails. Okay? And we'll use the random function and we'll use the choice function to show there's two different ways of doing it. Now, you can probably imagine this is extremely simple, but again, no matter how easy it is, practice is always worth doing. So we're going to be using our random library. So that means we definitely have to import our random library. So we're going to type import random. Cool. Coin flipping game. So every time the user runs it, we want to print out either heads or tails. So what we're going to do is first talk about how to do it with the randint function. And then we'll talk about how to do it with the choice function. So with my randint function, what I can do is I can generate numbers between 0 and 1. And if my number is 1, then we can say it's heads, or if it's 0, we can say it's tails. Well, that's a pretty simple way of doing it. So we could say, we can call it flip is equal to random, not randint. And I'll make a number either be 0 or 1 because they're right next to each other. So if I print flip, you get 1 or you either get 0. So yeah, we're only getting 1s and 0s. So we'll say that if our flip is going to be a 1, then we can print heads. Else, we can just print tails. If I run this, we get tails, we get heads, we get tails, we get heads, we get tails. So every time we run it, we're flipping our coin and we're getting something different. So simple, super simple coin flipping game using our randint function. Now let's go ahead and use our choice function. So I'm going to go ahead and comment all of this out. We're going to come down here and we're going to use our choice function. Let me make this a little bit bigger so it's easier to see. Now, with our choice function, we need to have some sort of list or a tuple, right, that our choice function is given. So we can have coin, right? And your coin has two sides. It either has heads or it has a tails. I might be wondering, Varun, why are you using a tuple here? Well, if you remember, a tuple is commonly used when you have a sequence of items that isn't going to be changed. By changed, I mean nothing's going to be added, nothing's going to be removed. That thing's going to be added or removed from this heads or tails list. So instead of making it a list, I made it a tuple. So now we can use our choice functions. We can say flip is then equal to random.choice, and we give it our coin. Now if we print our flip, we either get heads or we get tails. So every time I run it, I get something completely different. So let's go over both of these one more time. I'll uncomment this and comment this out. Oops. So what is our randint implementation of solving this project? So again, we have to pull either heads or tails, right? Because you're flipping a coin. Now, what I did was I determined that we're basically going to have the randint function either generate a 0 or a 1, right? Either a 0 or a 1. Now, if it generates a 1, then we'll just say that's heads. We're just arbitrarily assigning it that value. We might as well have said, if flip is equal to 1, then we could say tails, but we said heads. So if flip is equal to 1, then we print heads. If it's not, that means it's 0, so we can go ahead and print tails. Again, if I run this, we can print flip as well. We see the number. I print 1, so my random library generated 1, and since it's 1, we print out heads. So if I do that, 1 heads. So now I get 0 tails. So because this doesn't become true, right? Flip is not equal to 1 because it's 0. We can go ahead and print out tails instead. So pretty straightforward. Our choice function operates on sort of the same basis. It's a little bit shorter. So what we have is, again, our choice function takes a sequence. So it's either a list or a tuple. And from that, it pulls a random value. So what this is doing is we have a random sequence, right, heads and tails, and we've assigned that to our coin value. Our flip is basically just going to pull either heads or tails from this tuple. And we're using a tuple because a tuple is immutable and there's no need for us to change it. And by it, I mean there's no need for us to add anything to this list or, sorry, tuple, or remove anything from this tuple, because a coin can only exist as either heads or tails. Once I pick that, I just print out my flip. If I run that, we get tails, we get heads, we get tails, we get heads. So is everyone okay with that? Random library, using my random function, using my choice function to print out, what my coin has flipped to. All right, I'm seeing a yes. Perfect. Let's keep going then. So that's our coin flipping game. I'm actually going to go ahead and save that to a different file. Oh, I'm not sure. Okay. Oops. Which, is there a certain section, a certain function that you want to go over? Or should I just run through the whole thing again? Yes, they both work randomly because in coin flipping is one of those things that's it's just meant to be random. So we're just using our random library to sort of simulate that natural phenomenon of if you flip a coin, you don't know if it's going to be heads or tails. You want me to run through the code to understand the choice function? Yeah. Okay. So let's go back to our basics. Let me clear this actually so I can open up my console a little bit more. So what is the difference? So again, these two basically showing how with our random function and our choice function, how we're able to approach this problem differently. So what's the difference between the two of them? Well, our randint function is generating a number, right? It's either generating a 0 or a 1. And based on of that, so if our flip is 1, it gives me heads. Otherwise, it's going to give me tails. What my choice function is doing is, instead of generating a number, it's just straight up pulling heads or tails from this tuple, from this sequence, from this data container. So it's sort of skipping that number generation step. So that's the main difference, right? One of these is using a tuple, like a sequence, right? I could very well have made it a list and it would have done the same thing. So it's using a sequence. The other one is just using a number. Got it. But do they both work randomly? Yes, they both work randomly. Random.choice will pull values randomly from our list, and random.randint will generate either a 0 or a 1 randomly. That's why when I have this, just this, it's sporadic, right? We either get 1 or a 0, we either get heads or tails. If I come here and run this, I'm either getting heads or I'm either getting tails. I'm either getting heads or I'm either getting tails. So it's going back and forth. It's picking different values every time. So it might as well have picked heads from this list, and then the next time I run it, it might have pulled tails. It's completely random every time you run it. So they're both random, yeah. Yeah, the choice function would work with more than 2 words. So again, it's all about what you have inside of that list you're giving it. I expanded it to run 100 times and count how many of each it gets. Pretty interesting results. Yeah, we should actually try that out. Maria said, okay, cool. Would the choice option work with more than 2 words? Oh yeah, this is just for our situation, right, it's only heads or tails. So I've only put heads or tails in here. If you remember with our student example, I had Maria, I had Luke, I had my name, I had Ed, and it's able to pull, different names every time. So we could definitely have more than 2 words. But for this, I'm only giving you 2 words because it's a coin flipping. It's right. It's either heads or tails. There's no way I could have another option. Does that make a little bit more sense? Go try out. Luke said, yeah, of course. It's actually a great idea. Let's go ahead and clear this. And what we're going to do is I think we should use our randint. I like it a little bit more. Again, our choice, it's a little confusing. So we use our randint function to do this. So actually, I'm going to bring back what we had with our randint function. Okay. So we have our flip. And if our flip is equal to 1, we'll say heads. Otherwise, we'll say tails. So what we'll do is we'll create a counter. A heads counter. We'll create a tails counter. We'll start both of these off with 0. Every time you flip, you'll add 1 to the counter, right? So if I get heads, I'll add 1 to my heads counter. If I get tails, I'll add 1 to my tails counter. And then at the end, once we run it for 100 times, then we can say, you got this many heads, you got this many tails. So every time we get a heads, we want to, let's get rid of that print statement because then we're going to have a bunch of print statements. We'll just say heads counter plus equals 1. Again, this is how you increment. We touched upon this 4 lessons ago. And then we have our tails counter. Oops. Looks like my REPL is reconnecting. Okay, I think I'm back. So we have our tails counter now. Boom, boom, boom. And let's indent this. Put it in a for I in range 100 loop. So run this 100 times. And once that's run 100 times, we'll print our heads counter. And then we'll print our tails counter. So what are we doing? Let's go over this one more time before we run it. We're importing a random library to do our random numbers. We're creating 2 variables, a heads counter and a tails counter. So we can keep track of how many heads we get, how many tails we get. And now we're going to create a for loop so it runs 100 times. Within that for loop, every time we run it, we're going to generate either a 0 or a 1. If we get a 1, we're going to add 1 to our heads counter. It's like, so we're saying we flipped a heads. Otherwise, we're just going to add it to our tails counter. So if I run this, oops, invalid syntax. So, well, there should be a colon, not a semicolon. Run this now. Let's actually say, let's format this a little bit better. Heads. We have tails. Run this. We get 52 heads, 42 tails. And just it's kind of half and half. Let's increase this to 1,000 actually. So if we flip a coin 1,000 times, how many heads and how many tails do we get? That's not bad. That's actually a pretty good split. We get 508 heads, 492 tails. Let's increase this to 1,000 or 10,000 rather. A little bit less, but still pretty evenly split. 100,000. I'm just gonna keep adding. So not bad. Excuse me. So pretty split evenly. It's pretty nice. Let's try a million. I think this might be the upper limit of what we can do without our code like being really slow or breaking. And you can already see it's taking some time to run. Hopefully it doesn't break. Wow, this is also a pretty even split. So Python is pretty consistent. We get sort of close to a 50-50 chance when we roll flip our coin. So yeah, not bad. That was actually pretty interesting. That was a great idea, Luke. Yeah, that's pretty cool to just visualize, if you actually had the ability to flip a coin 1,000,000 times, that it might come out looking something close to this. So that was our coin flipping game. Pretty cool. We used our random library. We used a for loop, incrementing variables. So we touched upon a little bit of everything, and pretty interesting project. Let's go ahead and take this actually, and I'm actually going to save this to a file. It's always good to save projects like this to a file because, it helps you keep track of your progress. And it's also pretty nice to look at later on when you sort of reflect on how far you've come. So we're just going to make another file. And to do that, you're just going to open up this right here, add file. We're just going to call it coinflip.py. And I'll just copy this, or cut this rather, paste that. We can save that, show it to whoever we want to later on. Cool. So now let's move on to our next project. This is kind of similar to our coin flipping game. Again, it's just dice rolling. We're just going to roll a dice. However, we're going to format it a little bit better so it looks just a little bit nicer. So what do I mean by that? Well, if you sort of picture a die, you'll know it's sort of like a box, right? And then you have like a dot. I don't think I have my dot thing. You have like a dot. Oops. And then hold up. This is what like a die would look like if it's like 5, I guess. Trying to make it look nice. Doesn't look that nice. Like if you rolled a die, like this is what it looked like if you rolled a 5. I don't think this is a good idea, but you get the point. Never mind. We'll just do like a number instead. This doesn't look that good as I thought it would. Anyway, dice rolling. We're gonna again use our random library. Pretty straightforward. We're just gonna import it, import random. We're gonna come down here and we're just gonna print out. Actually, we're gonna say dice roll. We're gonna say that it's going to be random.randint 1 to 6, right? Because usually when you roll a die, it's a 6-sided die, right? That's those cube dies. So you're just going to do one from 1 to 6. We're going to print out our dice roll. We get 3, we get 3, we get 1, we get 2, we get 4. Pretty straightforward. However, usually when you play games like Monopoly, you don't just have one die, you have 2 dice, right? You roll both of them and you add them up to see what you get. So we're gonna sort of simulate that as well, because right now we only have one die or dice. I don't know what the singular version of dice is. I think is it die? I don't know. But let's create one that rolls it twice and then adds it up. So what we're gonna do is we're going to have a dice sum. We'll set that to 0. And what we're going to do is we're going to create a for loop that just runs twice, I in range 2. We're going to have a dice roll. We're going to print dice roll A. So the first dice roll is A, and then we put dice roll. We run this. We get dice roll to 1, dice roll to 2. And then we can say, we add that to our dice sum. So we say dice sum plus equals whatever we rolled on that roll. And at the end, we can print dice sum is, and then we have our dice sum. Let's run that. I roll my dice the first time, I get a 5. When I roll my dice the second time, I get a 2. In total, I get 7. I roll it again. If REPL will load, do a quick refresh. Let me copy this in case it doesn't save. But when we run it again, we should get, like a 4 for our first roll, a 6 for our second roll, and we add that up, we get 10. And it looks like REPL is being a little slow, but there we go. So it's saved. Let's print that out. So dice roll to 5, dice roll to 5, dice sum is 10. 4, 6, 10. Pretty straightforward, pretty simple. And right now we have about 40 minutes left. So now this is just a short one to just transition into what's next. Let's go ahead and save this. Is everyone okay with this one? What we've covered with our dice rolling game. Perfect. So you go ahead. I'll cut this. We'll save this to a file. We'll call it dice roll.py. Paste that there. Always fun to look at. Cool. Now we're going to move on. We're going to amp it up a little bit. We're going to be working with a game called Chohan. Now I've opened up the Wikipedia page for Chohan. And what I'll do is I'll take this and actually paste it into our chat, just so that you can reference it if you would like to. And I'm pretty sure if you copy that and you paste it, it'll work. Yeah, it works just fine. So Chohan is a traditional Japanese gambling game that makes use of dice. And well, we just so happen to have used die earlier. So the game uses 2 standard 6-sided dice. Well, that's very similar to what we just did, which are shaken in a bamboo cup or bowl by a dealer. The cup is then overturned onto the floor. Players place their wagers on whether the sum total, we did that, on the 2 dice will either be cho, which means even, or han. So we're going to build a game of Chohan. Roll 2 dice. We're going to roll 2 dice. Take their sum, or add it up. It is cho if it's even, and it's han if it's odd. Right? So cho is even, han is odd, and we place our bets on what it'll be. Let's go ahead and build our game of Chohan. I'm going to start by pasting. Oops. Copy our dice sum game, because that's basically the whole foundation of this. We'll paste that there, right? So far we've done the whole rolling 2 dice, taking the sum of the dice. Now what we need to do is determine if the dice is even or if it's odd. So I run this, dice roll to 4, dice roll to 4, dice roll to 4, dice sum is 8. How do I determine if something is even or odd? Well, the determination of even or odd is actually based upon when you divide by 2. So what do I mean by that? If I have 4, which we know is an even number, and I divide that by 2, I get 2, right? However, if I do 3 divided by 2, I get 1.5. That 0.5 is actually my remainder. So if you remember from our mathematical operator section a long time ago, we're going to be using our modulus operator to determine if something is even or odd. So I'm going to say is if my dice sum is able to divide into 2, right, without there being anything left, no remainder, then we know it's going to be even. Print dice sum is even. Otherwise, we'll be able to say that our dice sum is odd. So I run this, we'll be able to see the rolls, we'll be able to see the sum, and then we will see if it's even or odd. So dice roll to 5, dice roll to 5, dice sum is 10, dice sum is even. That works out. Let's see if we get an odd one. Dice roll to 2, dice roll to 3, dice sum is 5, dice sum is odd. Cool. So we've touched upon the rolling 2 dice, taking the sum. Now we have to determine if it's cho or it's han. So Again, since it's even, we're going to say it's cho. If it's odd, we're going to say it's han. That work? Han is odd, and 11 is an odd number. Cool. So we haven't really built out all of the functionality yet, because remember, Chohan at its center is a gambling game. So that means we have to take user input. We have to ask them to guess to see if they think it'll be either Cho or if it'll be Han. So we have our dice sum, right? And we have all of this. I should get rid of this really quickly. The first thing we're going to do is we're going to ask our user bet is equal to the input. Do you think it will be Cho or Han? And we'll say put either C for Cho or H for Han. Okay? And then we're going to do all of our dice sum and everything like that. So again, if our dice sum with the modulus operator by 2 is 0, that means we have no remainder, so it's even. So if they do that, then we know it's going to be Cho, right? And if they bet Cho, then we say, hey, you bet the right thing. So we can say, actually, how do I want to do this? Oh, yeah. So if the dice sum is even, right? That's what they're saying. And if the user bet is equal to Cho, capital C, right? That's even. Then we can print you win. Otherwise, we'll just say you lose, because that would mean that it's even, right? That the sum is even, but you picked Han, which is odd. So it doesn't match up. So you say you lose. Right? So that's if it's if this comes out to being even. Else, you can say if the user bet is equal to H, right? Because this else will only happen if we get our sum of our two rolls to be odd, right? This first one checks for even. That means that our last default is going to check for odd. So if it's odd and our user bet is Han, which is odd, we say print you win. Otherwise, we're going to say print you lose. So we go ahead and run this. So it's going to ask us, do you think it's going to be Cho or it's going to be Han? I'm going to say Han. Dice rolled a 5, dice rolled a 4, dice sum is 9. That's odd. So that means I win. Awesome. Let's run this again. Do you think it'll be Cho or Han? I'll say Cho. Or should I say Han again? That's right. What's going on? Let's sort of compare these side by side, our output with our code. So again, we have our first input statement, and that's going to save our bet. It's going to save if we chose Cho, or it's going to save if we picked Han. Then we're going to roll our dice. That is right here. So we're going to roll a 5, then we're going to roll a 6, and every time we roll, we're going to add that to our dice sum. Our dice sum is then going to get printed out, right? Dice sum is equal to 11. And then we're going to determine if our sum is even or if it's odd. If it's even, or in our case, it's odd, so we're going to default to this else statement. So we're going to check this now. So it's an odd statement, and I picked Han. So it's going to come here, and then it's going to start looking at these if statements. And since we picked Han, it matches up. So it prints you win. So let's run this. I'll pick Cho. I lose. So the sum was odd, but since I picked Cho, which is used for even, I lost. So there's your simple game of Chohan, a little bit of gambling. And of course, you could definitely build this up a little bit more. You could have like a while loop, so it just kept going, going, going. And you could have, your person have their own, income, like their own money that they can bet. So I want to bet $100. And if I bet that, then I win it back. So you could add that sort of functionality. Can you use elif, else if? Yeah, I'm assuming you mean like right here. You could definitely use else if. But again, since it's only two things, right? There's only two things. It could be cho or it could be han. You only have to check for one. That means the other one would default to the other thing. But you could definitely put like elif user bet is equal to han and make it like explicit like that. But again, it's one of those personal things. It all depends on how you. I meant on line 20. Um, yeah, it's the same thing that I mentioned here. There's only two options because it's either going to be, well, this checks if it's even. So if it's not even, then it has to be odd. So that's why I use that else statement because it has a default to that. But you could say something like elif the dice sum. You do like the modulus operator with 2 is equal to 1. That means there's a remainder. Then that would tell you it's odd. So yeah, I didn't do that because again, two options. We already checked for one, so we can just default the other one. So that is Cho Han. Pretty straightforward. We did that in about 10 minutes, so it was pretty light. Is everyone okay with that? For practice, can we try to make a dice roll function that returns a number? I like the way you think. I like that idea. Let's do that. Return keyword gives me problems. Hey, man, we got you, bro. Let's do it. Let's actually get rid of all of this. Let's just start from scratch. We'll build everything up. So there's no need for us to have to copy paste. We'll rebuild everything. So we're gonna do Chohan, but we're gonna use a little bit different functionality. So we're gonna use Chohan. Right? We know how Chohan works. We know that Cho is even, Han is odd. But we'll save those things for later. Right now, let's work on our dice roll function. So what we can do is we're going to create a function. Right? And how do we create a function? We use our def keyword, and we're going to call it dice roll. It doesn't take arguments right now, but we'll talk about that a little bit later. So again, we have to make use of our import statement as well. So we'll say import random, and we're going to have a dice roll. So let's start with what we know. We'll call it random number. Actually, we'll just call it. Actually, I want to call it dice roll because then we have like two things that are named the same thing. We'll just call it roll. Okay. And our roll is equal to our random.randint. We're going to use a standard 6-side die from 1 to 6, right? And we can print that out. And if I print dice roll, we get 1, we get 6, we get that. And we're getting none because I haven't returned anything yet. But what we can do with our roll is then we can just say return roll. So if we do this, we say first roll is equal to dice roll. We say second roll is equal to dice roll. In an ideal world, if I print both of these out, first roll, second roll, I get my first roll being 6, my second roll being 6. That's not a good example. Yeah, there we go. So my first roll has rolled us a 1. My second roll has rolled us a 5. So let's go through and see how this is all working. So the first thing we do is we import our random. Pretty straightforward. We're going to define a function. Now what this function is going to do is it's going to create a variable called roll. That roll variable will be any random number from 1 to 6 inclusive. And we're going to return that roll. Now, as I mentioned earlier, return allows us to save things to variables. So when I say first roll is equal to dice roll, it's basically going to save whatever this dice roll comes out to this first roll, which in this case was 1. Same thing here. My second roll, this variable will be equal to whatever my dice roll function returns, which in this case was 5. So that's how your dice roll works right now. So if we run this, we get a different thing every single time. Does that make a little bit more sense, Luke? How are we feeling about that? Obviously, we're going to keep building this, but so far, so good. Awesome. So we have our dice roll right now. It's pretty great. It does what we need it to. But let's actually create something that allows us to roll multiple times. Okay? So what I'm going to do is inside this function, I'm going to set a parameter. And we're going to call it number of rolls. Okay? And we're going to set it default to 1. So what am I going to do with this? Well, basically, I want to create a function that given, let's say I want to roll 3 times. It's going to say what each roll gave me, and then it's also going to print out the sum of all my rolls. So right now, I'm only rolling 1 time. If I wanted to change this to 2, for example, I could do is I create a for loop. So let's get rid of this actually. For I in range, number of rolls I want to do, number of rolls, we're going to make a roll, right? That's a random.rand int from 1 to 6. And we're going to have a nice sum to go to 0. And every time we roll, we're going to add that to our dice sum. Okay? And then we're going to print out, we're going to use an F string for this. How do we do our F string? Let's create our base. On roll number, whatever, we got whatever. On the first roll, we got boom. On roll number 2, we got whatever. So we can actually use our I variable for that. Come here. And then we can just use our roll right there. Again, I'll talk about this, but let's just, let me go through it and then we'll look at how it's actually working. We can just return our dice sum because that's really the only thing we need. It's nice to be able to see the roll numbers, but for the sake of Chohan, the only thing that you need to have saved somewhere is your dice sum. So what we can do is if we do sum is equal to dice roll, let me just print that sum out. We're only doing 1 roll. And it says on roll number 3, we got 3. So let's actually change this to I plus 1. Why is it coming out to being 0? Because if you remember from your range function, it always starts at 0 and then goes up to, but not including. So we're just going to change that to I plus 1 so it doesn't say roll 0. On roll 1, we got 1, and my dice sum is equal to 1. That's because my number of rolls has been defaulted to 1. Can you redo this? Oops. Yeah, let me just talk about what we've done so far. I think I got a little ahead of myself there. Anyway, what I wanted to do with this function, do you always have to define the variable in the function rather than before like you did with dice sum? So with the dice sum, I'm defining it before in the function. No, I'm only defining dice sum within the scope of my function because that's the only place where it needs to exist. It doesn't have to exist anywhere outside of the function. And I'm keeping it before my for loop because if I put it anywhere else, like if I put it in my for loop, it'll just keep resetting the value. So if I put dice sum in here, right, dice sum is equal to 0, then every time I run this for loop, you'll add something to the for loop, into the dice sum, but then as soon as you run it again, it'll get set back to 0. If I put it after, then Python won't be able to run this because that dice sum wouldn't have been created by then. Yeah, let me go through it one more time. So if you define dice sum before the dice roll function, it would still work. Yes, that would still work. So actually, oops, never mind. Unbound local error. Local variable dice sum referenced before assignment. They know it would not work. It's all about the scope of where your variables exist. And I thought it would work, but I don't know. But yeah, I forgot about this one. It's all about just try to keep things like where they belong. And what I mean by that is this variable should only be one of those things that's accessible in here, if that makes sense. Okay, so let me actually go ahead and talk about this one more time. So what I've done here is I've created a function called dice roll. And this dice roll function gives me the ability to choose the amount of times I roll my dice. Right? So I can either roll it twice, I can roll it 3 times, I can roll it 4 times, I can roll it 5 times. However many times I want to roll it, I can do that with this function. Now, I've given it a default parameter. So by default, if I call this dice roll function, it'll just roll the dice one time, right? And when it does that, if we have a situation where we're rolling it more than one time, right? We want to be able to tell what our sum of our dice is. So what we're going to do is we take, let's say the user gave us 3 rolls. They want to roll this 3 times. So this becomes for I in range 3, right? We're going to run this 3 times, this for loop. We're going to roll our number. We're going to take our number that we roll and we're going to add it to our total sum. And then we're going to say, on this roll, you got this. So I run this right here. Right? So this is running 3 times, right? So we're just assuming that they gave us a 3. So they want to run or roll the dice 3 times. So on the first roll, we got a 4. On the second roll, we got a 5, right? That's what's happening right here. On the third roll, we got a 3. So we've rolled it 3 times. And every time we roll it, that roll gets added to our dice sum. So the first time we rolled, we got a 4. So our dice sum was 4. The next time on our next iteration of our loop, we got 5. So our dice sum was 4 plus 5. So it's 9. And then the third time, the last time we ran our loop, we got a 3. So that gets added to our dice sum as well. So we have 4 plus 5 plus 3, which is 12. That's our dice sum. This dice sum then gets returned to this sum variable, which is in turn printed out, which is why you have this 12 right here. It is the returned value from this whole dice roll function. And the reason why I have this I plus 1 here is if I don't have that, on roll number I, it's because it looks like this. On roll number 0, that doesn't really look right. So I just added a 1 just to fix that. Because when we count, we start at 1. We don't start at 0. So if I replace this with number of rolls, if I run this normally, right, I haven't given it an argument. So that means we're going to use our default value for number of rolls, which is 1. So we're only going to roll 1 time. And we got a 1, so that means our dice sum is 1. So if we run this again, got 1. On our first roll, we got 6, so that means our dice sum is 6. If I change this to 2, right, I say number, or I say 2 right here, it's going to roll twice now. If I put 5, it's going to roll 5 times and then give me the sum as well. Luke asked, does print dice roll give the same result? Yes, it does. It does the same thing. I'm just zipping it to the sum, so it's easier to look at, but you very well could have done print dice roll, and then however many rolls you want to do. Let's say 3. We've rolled 3 times, and we've gotten, and this, right, all these rolls are happening within the scope of our for loop, and then when we print this right here, we get the total sum. So is everyone okay with what we've done here so far? And I'm saving this sum variable. I'm saving it like this right now because we will be using our modulus operator because we're still building our Chohan game. But is everyone okay with what we've done here so far? It's all good. Again, if it's like for loops and stuff and like incrementing, then we have all that saved in our previous lessons. So I think we're okay. I haven't seen any questions yet. So I'm going to assume that we're doing fine. So let's collapse this dice roll right here. As again, we've sort of figured that all out. What we're going to do is in Chohan, right, you're rolling 2 dice. So we'll just say sum is equal to dice roll, and we're rolling it 2 times, right? The number of rolls is 2. Now, if our sum, right, is divisible by 2, and it doesn't have any remainder, which makes it an even number, we're going to print sum is even. Otherwise, we're going to say sum is odd. I run this. We see the number of rolls, and then we see what our sum is. So we got a 5, we got a 2, we know that's 7. So it makes sense that our sum is odd. Cool. Now we can take that part we did earlier where we take the user's input. We ask them if they think it's going to be Cho or if it's going to be Han. So we're going to say user bet, define it after our function. Say user bet is equal to input. We'll just make it really simple. We'll just put C/H because we already know what it is, Cho or Han. So if it's even and our user, it's Cho, which means odd. Sorry, even. It gets so confusing. Let me say that again. So if our sum is even and our user picks Cho, which means even, right? If they both agree, then we print you win, yay. Otherwise, we'll just say you lose, no. All right. And with this, we know this is for when it's odd. So if it's odd and our user puts Han, which is odd, then they win. You win. Otherwise, they lose. You lose. Run this. Cho or Han, I think it's going to be Cho. I lost. So on roll number 1, we got a 3, and roll number 2, we got a 6. 3 and 6, that's 9. That is not even. So let's split Han this time. I lost again because 5 and 1, that's 6. I won this time though because on roll number 1, I got a 3. Roll number 2, I got a 2. Add them together, that's 5. That's an odd number, and I picked Han, so I win. So yeah, there we go. That's our game of Chohan implemented with a function that returns us the number of die. And it's pretty cool because we can actually make this 3 rolls, right? So we don't have to just roll it twice. You can roll it 3 times. So pretty awesome what we've done there. Capital H. 224, so that's 8. So yeah. How are we feeling about this so far, guys? Can you display the dice roll? Yeah. Again, we have our default. It defaults to 1. And we override that default whenever we set the argument or whenever we give it an argument. And we're doing this I plus 1 because you remember for your range, it always starts at 0. And it sounds weird when you say on rolls number 0. So you add 1 just so that makes a little bit more sense to read. So how are we doing with this so far? Everyone okay? I'm a bit confused. Okay. Were you okay with when we did our Chohan, like like the first time, like our first Chohan game before I deleted it, before we switched to doing with a function. That makes sense. Why do you print you win, you lose twice? Okay, so that is actually for, I can break this down for you actually. I'll use some comments to help me out. So if the sum is even, right? Because that's what this is saying. So if the sum is even, and if the user guesses even, because that's basically what they're doing here, right? That's what cho means. Cho means even. So if the sum is even and the user guesses even, then that means they win. If the sum is even and if the user guesses odd, because that's basically what this is saying, this else statement is saying, then we're going to lose. So this is only for when we're doing our evens. If we want to check our odds, right? So if the sum is odd and if the user guesses odd, then they win. But if the user guesses even, then they lose. So the reason why we have 2 you wins and 2 you loses is because of the way we've sort of broken it up. So again, it's all about if the sum is even or if the sum is odd. So we sort of split it into 2 branches. And the 2 branches, right, even or odd, you still have to check to see if the user has guessed the right thing, if that makes sense. Does that make sense with how our logic is being used there? Okay. Yeah, so it's I can just like read it out. Like I like reading it out in like plain English. Let's say I'm gonna tell Python, hey, roll my dice 3 times, right? That's what this is saying. And save whatever that my 3 rolls is to this variable called sum. So if my sum is an even number and the user has guessed cho, which means they've guessed even, that means they put the correct bet. Okay, but if my sum is even and the user guessed han, if they guessed odd, that means they didn't get the right thing. So that's my one branch, right? My even branch still has to check to see if they win or they lose. My other branch is my odd branch, right? This one right here. And from here, I also have to check to see if they win or if they lose. So that's how we have our 2 wins and our 2 you loses. So we have 8 minutes left so far. I don't think that's enough time for us to work on our next project. But what I will do is I'm going to pull it up, and I'm actually going to copy this link and paste it in the chat. So if you guys want to, I don't know, like work ahead or take a look at it, then it's there for you guys to do so. This is exercise number 18 on the Practice Python website. And it comes with, it basically covers the same things that we've talked about: randomness, functions. Don't worry too much about this whole main method thing. That's not, we're going to talk about that a little bit later, but it'll literally walk you through how to do that. And then, when we come back for our next lesson, I'll also do that. But for tomorrow's review lesson, which again is from 12 to 12:30, I will literally just go over everything we did today one more time, just to make sure that everyone is sort of a-okay with what we've covered. But we still have 7 minutes left, so if there's any lingering questions, if there's anything you guys want me to add in terms of functionality, I'm more than happy to do that right now. Or explain anything that as well. Okay, I'm not seeing any questions. Just going to assume that we're all good. For fun, throw a sleep function in there while the dealer rolls the dice. Not bad. Let's do that. Look, you got some great ideas, man. So we're going to import our time function, right? Because that's what we're going to use to add our delay. And what we can do is we'll say, we'll just say print. Please wait as the dealer rolls the dice, right? So we're going to say, please wait as the dealer rolls the dice. We'll add a little delay in there, time.sleep for 1 second. And then they're going to roll the first dice. And after they roll the first dice, we're going to add another delay. We'll say this is also for half a second. We run this now. It's going to ask us Cho or Han. I'll say Han. Please wait as the dealer rolls the dice. That was nice. It added a little delay there. Let's actually increase that delay so it's a little easier to keep track of. We'll say 2 second delay, and then we'll say 1 second on this one. And we'll put our dice roll at 2 instead of 3. So Cho or Han, I'll say Cho. Please wait as the dealer rolls the dice. Nice. So yeah, that sleep function definitely makes it a little bit more interesting and more appealing than just everything being printed out as quick as possible. I think I would like for us to revisit this tomorrow, this last game, definitely. And I'll take a look at this and see if there's like a better way for me to illustrate and make it make more sense, because it is pretty confusing the way I've went over it. So we'll definitely talk about this game as well tomorrow. I like the sleep function. I know our sleep function and our random function, they're just tip of the iceberg. There's a lot more that we're going to talk about. We're going to be making whole applications and everything. So yeah, I think we're just going to go ahead and call it for today. Again, be sure to check out Practice Python Lesson 18. I don't think we're going to touch upon this in tomorrow's review lesson. I think I'm going to save what we've done today and go over just about everything we did today in tomorrow's review lesson. What time is the review tomorrow? Well, tomorrow's review will be 12 p.m. Eastern Standard Time to 12:30 p.m. Eastern Standard Time. So only 30 minutes. Obviously, if we need more time, I don't mind. We can go for 45 minutes. We can go for an hour, as long as we need to make sure we got everything figured out. But yeah, guys, thank you so much for another great lesson. I think this is my 10th stream so far, so it's been pretty good, and you guys have been a blast to teach. Yeah, of course. Thank you so much for your great questions and those suggestions you had to make our projects better. That was awesome, and I'm glad you're like getting into it. You guys are definitely going to be doing great stuff. Don't even worry about it. But yeah, everyone take care. Keep practicing. Seriously, that is like number one priority. Keep practicing throughout the week, even if it's only 10, 15 minutes. Take a look at our old lessons that are still recorded. Hopefully this is going to get recorded, but I've been recording it on my end. So we'll figure that out. We'll figure everything out. If you need to reach out to me, all of my links are on my Teach.tv page. I think that basically covers everything that we've done today. So good work, everyone. Right? Like we're doing pretty awesome. We're kind of professionals with this now. So yeah, take care, be safe, stay healthy, and I will see you guys tomorrow.